All right. Good morning, good afternoon, good evening, depending upon your time zone. Welcome to our webinar. This is the second in our seven-part series on search and artificial intelligence. And today we're going to be talking about product and e-commerce search. We have Sanjay Mehta. I'm going to let him introduce himself in a moment. Patrick Hopeful and Phil Ryan. And I think Patrick's having a little bit of trouble logging in, but we'll hopefully by the time we get through introductions, he'll be here. So my name is Seth Early. I'm founder and CEO of Early Information Science. Many of you may know who I am or who EIS is. We're a professional services firm. We've been around for 25 plus years, coming up on 30 years. I wrote a book on artificial intelligence called the AI-Powered Enterprise about 4 years ago. Pre-LLM, but everything still applies. Sanjay, why don't I let you give a little introduction?
Hello, everyone. Sanjay Mehta, and I'm a principal architect. And my background's been more in e-commerce. That's why I'm here. I've been with many of the leading vendors, probably a lot of the platforms you may be using from a B2C, B2B perspective, as well as leading e-commerce search platforms. And excited to talk about what we're doing and the applications with the AI and Gen AI for commerce today.
Great. And thank you, Sanjay, for joining us today. And Phil, do you want to go ahead and give a little bit of your background?
Absolutely. So I'm Phil Ryan, Senior VP of Strategy and Innovation at LucidWorks. Been working in the search space and in the e-commerce search space for a couple of decades. Most recently, I've been working on Gen AI and its application in e-commerce as well as in knowledge management. So really excited to talk about what we've been working on.
And Patrick, hopefully, will be joining us. He's having some technical difficulties, but he is someone with a great deal of search and AI expertise. Had been partners in crime with both Sanjay and Phil in prior organizations, including LucidWorks. So hopefully Patrick will join us. We are recording today, so if you want to pass this on to someone, or you have to drop early, or you want to re-listen to pieces of it, that will be available. We're going to shoot for about 50 minutes, but we'll see how the time goes. We'll leave time for Q&A, but you can ask questions as we go. And there's also a couple of polls during the session and then one afterwards. So we do appreciate your input and your feedback. I did mention EIS. We are a professional services firm. We're based in the Boston area. We've been around for quite a while, and we work across lots of different industries. Just a few of our customers down there. We have slides of logos. So we've been doing business in this space, and we have a lot of deep expertise, especially in the information architecture to support artificial intelligence. I coined the phrase, there's no AI without IA, in an article I wrote back in 2016. So again, this is the 7-part series. You can see the upcoming sessions. We're going to be talking about search generative engine optimization, which is SEO for generative AI. We're going to talk about accuracy and reliability in generative AI mechanisms. We'll get into issues around the practical reality of large language models and what we have to think about in terms of execution and implementation and deployment and operationalization and all of those pieces. We're also going to hear from vendors and hear about the strategies and the challenges, not from a vendor pitch perspective, but really from a here's what's going on in the industry and the technology. And then we want to talk about how AI is impacting people's lives and livelihoods and how people need to make changes in order to keep current and keep their skills up to date. So today is product and e-commerce search. And what I want to do is start off with, where are you on your e-commerce AI journey? So Carolyn will put that poll up and go ahead and, is it not on the radar? Are you planning for base applications? Are you using controlled experiments? Is it currently banned? I see a couple of those. Is it in applications that are deployed? So I see some none of the above. And if it's a none of the above, why don't you let us know in chat? So I'm just texting with Patrick while we're waiting on that. This is really strange. Maybe restart your computer, Patrick. Okay, let's keep this open for just a moment more. The analogy is popcorn popping. So it starts off a lot of stuff happening and then we slow down. Why don't we go ahead? I don't see any more folks responding. So it looks like a lot of folks are doing controlled experiments. Let's go ahead and share that. Go ahead and get your last choice in. All right. So we're sharing the results, and you can kind of see that there's a few it's not on the radar, and then there's some none of the above. Again, let us know in chat. Looks like currently banned is one organization. Let's see what we have. So it looks like a number of folks are planning this or in the controlled experiments, but nobody's really completely deploying this, which is par for the course. It's not unusual. And let me see if I have anything else here. I'll say answer live, done. Okay, so let's continue on. So we wanted to, again, we're talking about this in terms of e-commerce strategy. How do we improve e-commerce search, specifically search? But there's lots of different perspectives on what search is, and we can also use AI to address product data challenges, right? A lot of times we say that good data is the price of admission. Well, how do we get those table stakes satisfied? And we're going to talk about a way to do that. And then how do we use this to contextualize that experience, personalize that experience, and then what is the role of a reference architecture? And I did not get a picture of a reference architecture, but we'll talk about what that is. There's a lot of hype, there's a lot of noise, but the potential is very, very real. So it's important to understand how these things work. It's important to understand the mechanisms and to understand the limitations of Gen AI in e-commerce. But because a lot of vendors are selling what I call aspirational functionality, right? They're not quite there. They're trying to get there. They have good PowerPoints. They have good demos. They have a nice user experience, but they're not quite there. And it takes time for that maturity to happen. So what questions do you have to ask? And what are the limitations you need to be aware of in order to do this effectively? Because we're not just going to be talking about motherhood and apple pie here. We're going to be talking about, the real limitations and the real challenges of this stuff. So let's continue and talk a little bit about this. And here's kind of a scenario. And I think, Phil, you are going to talk about this from the perspective of a real life experience when you go into, say, Home Depot and you're asking for help. So, Phil, do you want to kind of lay these scenarios out?
Yeah, mute.
Sure. I think we've all had this experience where we've got some do-it-yourself project at home and we need some piece or part from Home Depot, and you go in and there's a couple of possibilities when you go into Home Depot, and I think we probably had both, most of us, if those of us who are do-it-yourselfers. You might get Brandon, and Brandon's a great kid. He's smart and he's eager to help, but bless him, he hasn't done much in the way of do-it-yourself, let alone construction. And if you ask him a question, he'll probably check his app on his little Home Depot app on his phone, and he'll be able to say, yeah, this piece that you're looking for, it's over on aisle 15, but he won't be able to tell you anything about it. He certainly doesn't know anything about your project. And that's the experience that you get with Brandon. The alternative, and I think we've probably had this experience as well, is sometimes you're lucky enough to get Jake. And Jake he's probably 65, 70 years old. He's been a general contractor for 40 years, and he's forgotten more about construction and do-it-yourself that you'll ever know. You hold up some kind of bolt or piece or part or something, and he immediately recognizes it and says, yeah, that's over here. And he can not only can find where it is, but he'll tell you all the things. He knows more about your project than you do, and he'll tell you what you need. He'll remind you of some things that you may have forgotten. You can ask him questions and have a conversation about your project and say, well, what about this versus that? He's giving you context. He's giving you experience. He's giving you essentially the interactive experience that basically allows you to not only purchase with confidence, but have a more successful outcome. And that's really what Gen AI can do in the digital experience. You're providing a level of context and inference and natural language understanding and conversational interaction that can provide a very positive purchasing experience.
Yeah, in addition to finding what you need and finding the related things, it can also give you that level of expertise, which is really what's exciting about this. Sanjay, I think you were going to talk a little bit about kind of the search perspective on lots of these different things, but I really love the Brandon Jake analogy, because that is what we want to do. We want to be able to get what we need when we need it. We also need to get that additional experience when we need that, right? So it's the appropriate experience when we need, depending upon our context. So Sanjay, you wanted to talk a little bit about search and retrieval across this ecosystem of e-commerce functionality.
Yeah.
Patrick, we're just talking about you having technical. Yay, thank you for resolving those. That's great. So
yeah, thanks.
Awesome.
Great to be here.
Go ahead, Sanjay.
Yeah. So I think a lot of folks who use search might sort of silo it into just finding, the product results. And I think to take it back up is there's, across the board, search can facilitate many other value-added use cases in e-commerce, right? And for example, whether it's used to create landing pages or category or listing pages that you want to have exposed to the external search engines like a Google for SEO, right? Or use it to produce certain types of results for a certain campaign, right? Those are kind of common scenarios. So I think let's make sure we look at that and think about where the Gen AI piece can be intertwined as well into that search experience. Seth already kind of brought up the idea of product and content enrichment, and we definitely see this kind of more on folks who are just starting to test out sort of the AI and search, where they might want to just look at improving the data and testing out how the data enrichment or improvements from like a Gen AI model will impact results versus actually changing or having a dialogue or changing their user experience on the front end, right? And so that's that scenario, which is showing some great results out there. Let's not forget, of course, how it augments the search experience itself, right? Where you've already, for those of you probably maybe in Google Labs or others have seen more of a generative response that you get, right? That has a little more conversation attenuation to your results, but also where it might even help drive the navigation. Think about how it prompts you and guides you based on finding information by predicting maybe what you want by your similarity to other users. And of course, let's not forget like the chat type of scenarios, which are, I think many of you might be familiar with from the ChatGPT perspective, and how powerful and the types of results that type of interaction drives. And then we did talk a little bit about, but search, of course, we understand what the queries are. It is a mechanism to get your customer intent, your audience. What are folks searching for example? What's the underlying context when they're searching? But think about now the Gen AI enhancing that, where, extracting more of that intent out of the query or the searches, and what folks are looking at and ultimately looking at, and using the Gen AI to extract the content they're looking at to really come up with a very highly refined view of that user, which can then be used for personalization, right? And really advanced personalization. Of course, search is great at doing recommendations, whether it's not just similar searches, but using kind of a vector search model to show similar items, for example, is a very common scenario. And let's not forget about we're talking about the top of the funnel and going to mid funnel, but the kind of bottom of the funnel with the self-service. Most of you most likely have some form of customer self-service, and so having the search provide that, and Gen AI does a great job of helping, like in use cases like troubleshooting, and is key. And then when we think about where you can go with a deeper level of analytics and insights, having the ability to mine the data using search technologies paired with Gen AI is monumental, right? Where you can really grab some deep level insights from the content analytic perspective, for example, plus behavior analytics. So there's a lot. We're going to, definitely focus more on the search piece today, but just to give folks, a sense of what we're seeing out there.
Yeah. And thinking about it from this perspective gives you that very broad sweep of what retrieval is. It's not just putting terms in a box or we're having a chat conversation. It is really about surfacing information in these different contexts, right? Faceted navigation is really search. Search can be behind the scenes and can power a lot of this experience, and Gen AI can be behind the scenes powering a lot of this experience without it being explicitly search, right? It is part of that overarching user journey and user experience. So what I wanted to do is I wanted to find out, well, what are you considering AI in e-commerce? So take a look at this list. These are the ones we just talked about. And again, are you looking at this from the SEO perspective? Are you looking at this from a product and content enrichment perspective, search and navigation, or conversion or conversation? Are you looking at this for personalization, recommendations? And I know there's overlap between these. This should have been a select all that apply. My bad. I should have selected all to apply. So I know it's hard to pick one you're probably doing. So just pick the one that's primary at this moment. Give you a couple more minutes. So really, it is about the navigation and conversation for the most part. But we're seeing some other areas. Interesting to not see so much in SEO. But again, this is broadly looking at AI and e-commerce. a bit of a self-selected audience, right? Because we did talk about this as a search in e-commerce. So maybe that's part of the bias, but I should have allowed you to select all that apply. So let's go ahead and looks like folks have participated. So we can go ahead and share those results. And again, search and navigation and conversation is the big winner, but could be from a self-selected audience. So we'll finish with that. Any comments from the panel on on what you've seen from that? It's typical. It's not unexpected. So let's go ahead and talk about. I'm sorry. Was there a comment?
No,
Okay.
just not surprising. That's exactly about what I would have predicted. So good.
Yeah. So one of the things that we need to consider is the fact that we have to have good product data. We have to have good content. And one of the main takeaways here is that AI can assist with data enrichment. It's not a matter of you throw crappy data at it. It's a matter of you have a very specific process for enriching the data that you need to have enriched. And we'll show you what that looks like. And it does require a reference model. And the core mechanism here is getting your content and your data into a space that can be queried. And we'll talk about vector embeddings. We'll talk about enriching those vector embeddings with metadata. We'll talk about other contexts that can help provide that enriched data and the enriched data structure from things like your audiences, from standards, from other web pages, from corporate ontologies, from tech specifications, right? There's lots of other pieces of content and data sources that will help when you enrich your data. So we're going to walk through a little bit of this, and this is where we need to have those ontologies. This is where we need to have attribute models and product data models, at least to understand what we have, right? And to say, here are the product categories that are important to our organization. You may not have good product data, Phil. You may not have the right attribute models, but you can begin with an ontology, you can begin with different standards, and you can begin with other artifacts that can be ingested into a vector space to help you enrich that information. In this case, in this situation, this is a case study for an industrial parts manufacturer. And what you have here is, and this is using retrieval augmented generation, right? It's using RAG, but it's using modular RAG, which is a much more sophisticated version of RAG. Retrieval augmented generation is saying, retrieve the information from your data source. And in this case, our prompts are actually the data that we need to enrich, right? So we can do this programmatically. We can say, here's a product name, and here is a product description, and here is a set of attributes. I want to enrich those. So I'm going to put those in as the prompts for my RAG system. And then I'm also going to ingest other things, right? So we have attribute names, that's the original attributes. We have the original schema. And then we say, well, let's also bring in web pages. Let's bring in digital assets, images. Let's bring in product specification sheets, any knowledge bases. Many times the data, the right data, is locked up in PDFs somewhere, where it's in engineers' heads, but many times it's in specification sheets and in data sheets. We want to understand who the target audiences are. We want to also bring in rules, governance, any standards bodies, any style guides that we've created, any types of search index rules, any branding, right? We want to respect our branding guidelines. And now notice under third-party intelligence, we have the actual large language model. That's considered third-party intelligence here. And we have as third-party intelligence Google API and the Google Graph, because what we're doing is we're also using that as an additional source of data. And we have what you see here, an MRO knowledge graph. It says EIS because that was created by my company, by Early Information Science. This was ingested into this model in order to provide additional context. So this is us creating the human curated terminology, the ontologies that act as part of the reference model. And then, of course, we have user context. We have user telemetry. We have the digital body language, search analytics, real-time clickstream analysis. All of these things change that user context and allow us to be able to take those signals and use them for additional inputs into the LLMs to get what we need, and KPIs, audience segments, and so on. So the first thing we do is we merge those documents and that content into a unified index. We generate embeddings, and we're going to talk more about what embeddings are and look like. And we're creating this vector index with these different perspectives, with these different contextual ingestions, right? So we have industry and organization specific ontological embeddings. We have the, here's the graph index, industrial distribution taxonomies, and all of this is providing additional context for this. Here's audience application and behavior. And then you also see the Q&A embeddings. If you have customer service calls, if you have people who have dialed in or had chats with customer service reps or engineers, all of these things can be brought in to generate the context in the LLM and its related metadata. And what this is really breakthrough stuff, right? And this requires modular RAG, just like we used to have search pipelines, right? You have to think of modular RAG as the different modules are like search pipelines. We had a different pipeline process for geospatial or temporal or time series or structured, unstructured information. You process those differently to have a unified index. We have the same idea here with modular RAG. And then this is what it ends up with. So what is the output? Here's the input, right? Here's a category code, the category name, brand, right? And the series name. Now, what we do is we say, well, let's normalize this and let's draw from internal and external sources and publicly available information. And we also this conforms with any guidelines, any style guides, any industry standards. And we enrich the SEO information and the metadata for all the records. So we use this as a programmatic approach, an agentic approach. So we cycle through each of the records, and this can be hundreds of thousands or millions of records. And this is what we end up with. Acme shorting bar for electrical terminal blocks, a dedicated shorting bar designed for use with electrical terminal blocks to create a secure electrical connection suitable for automotive manufacturing automation applications. Keywords, shorting bar, electrical terminal block, short circuit prevention, relevant categories, and then the reasoning. This is what's really super important, is the reasoning. How did you get there? So this is the type of thing that is essential and critical for being able to do search, but it's preconditioned. It's a precondition. It's setting the stage. Sanjay, did you want to make any other comments on this? Or Bill, Patrick, any thoughts on this approach?
I think for e-commerce folks, it's this is a pretty known issue of having sparse data, and really maybe testing how this could improve. Where you try when you think about testing improvements is where you test what the result looks like and how it's impacting your, like, for example, conversion or sales versus what you had before is something that comes up. It's like, how do we test this sort of thing? But just to throw that out there, something that can be done.
Absolutely. Phil, did you have a comment?
I was just going to say that the way that you laid that out there is very nice. It's a very practical representation of how we can pull all these pieces together. So
yeah, and it's very, very exciting. Patrick, if you have a comment, great. If not,
yeah, this is our first major recommendation that you take advantage of to augment your data or enrich your data using large language models, because it can take what is on the left and turn it into what's on the right and make it a much richer data set than what you would otherwise be able to do. And it does it programmatically instead of having to have a user sit there and type it. So this is great.
This is a fraction of the cost, right? And even a couple of years ago, trying to use AI for this, it was very labor intensive. You had algorithms that were specific to a product category. There was one vendor that had a whole army of programmers, and they would push this out to this, this crowdsourced programming, but it was done category by category, right? It was very, very cumbersome. So this is really astounding breakthrough stuff these days, and I'm very, very excited about bringing these to different organizations. Phil, you want to talk about vectors and vector spaces. So why don't I let you kind of describe what this means and what multiple dimensions entail?
Yeah, absolutely. So vectors, and you can think about vectors as and embeddings really as synonyms, right? So what's a vector? A vector is a coordinate in a vector space. And what's a vector space? Well, you can think of a vector space like a map, where similar things are found close together. So we've got a picture here of a geographical map with latitude, longitude, and altitude, and that gives you an idea of where you are. You can extrapolate that three-dimensional space, though, into lots of other components or lots of other features or dimensions that would describe a concept or an entity, right? So if you're thinking about a restaurant, there's obviously the physical location, but then the fact that it's Italian and it's 5-star and it's expensive, that it does or doesn't serve ravioli. All of those components are elements of a concept, and that lives in a vector space, and it can be represented by these numeric values for each of those dimensions. Those dimensions aren't necessarily explicit and discrete in a dense vector space. They are latent features that are sort of emerge from the from the context. And like if you think about a piece of music, there's the melody and the rhythm and the pitch and the various components, the timbre that make up a piece of music, and other pieces of music might be found in that spot. And you wouldn't necessarily be able to map every one of those features to a particular dimension. In a dense vector space, that's how concepts are represented. And they're represented as scalar values. So every one of those latent features has a number associated with it. And what we do with that then is that where this fits is that's what an embedding model does. An embedding model takes a concept and gives us a representation in that vector space. It comes back with a coordinate in a vector space. What we feed into that could be a product, it could be a term or a word, it could be a query. So when we want to use an embedding model for search, what we do is we say, hey, here's a query. It has a representation in that vector space. And then we can look and find all of the products that are similar in a similar location in that vector space. So how does this
is a math? I'm sorry, I didn't mean to cut you off.
Well, I was going to go to the next slide, so go ahead.
Oh, sure. Yeah. So the vector is the mathematical representation of the whatever it is, whether it's a phrase or a term or product. And then it has n dimensions, right? It's n dimension. So, we've seen, we can think in 3 dimensions, but we add these other parameters here. We can see, oh yeah, there's multiple dimensions. We'll think of it as thousands of dimensions or tens of thousands of dimensions.
Yeah, absolutely. So how does this work in the context of e-commerce? And Seth was talking about RAG. Usually there's 2 pieces, and this is a sort of a simplistic representation. Often there are multiple embedding models and multiple generative models in the context of a particular solution. But the basics are you have, first of all, a piece of text or a query that we send to an embedding model, and we get back a numeric representation, a vector with a number of dimensions. And as Seth pointed out, that can be any number. We can use a smaller number of dimensions, like 384 is a common one. Sometimes we go to 1048, but there's 1024, but there are lots of options there. And then once we have that representation, or the other thing that we can do with text is we can give it to a generative model. And what a generative model does is it uses vectors under the covers, but it doesn't spit out vectors or embeddings. What it does is it spits out text, or more accurately or more generally, it spits out data. A generative model looks at and is trained on lots and lots of different types of data. That could be text, it could be other things, and it can create similar data based on the patterns that it has learned from that. So that's how the embedding model differentiates or is different from the generative model. When we talk about LLMs, we're usually talking about generative models. So how does this work in the context of when you're actually talking to an LLM? There's a couple of different components to this. There's the prompt, and the prompt is usually it's a question. It can be a question combined with some additional data, some product data, or some other. Seth talked about articles, and the reason that Jake in the digital Jake can know about your project is because they're relevant articles that you have brought into this prompt and said, hey, answer this question in the context of this how-to guide and in the context of these 5 products. You can put all of that into your prompt. You feed it into a generative model. That generative model could be, GPT, one of the GPTs. It could be Gemini, Claude. There's that prompt then goes in, and what it comes back with is data. It can come back with a recommendation. It can come back with, as Seth talked about before, there could be some additional context around the product data itself that you want to add. And you can ask the model to respond with inside a particular length, using a particular style or tone. Any number of ways that you can characterize and describe. You can actually ask for a specific format. I want it in JSON format. And so there's lots of different options in terms of what you get back, the nature of the data that you get back from a generative model. And so if we pull all this together in the context of RAG, Essentially, what we're doing is we've got at index time, what we've got is we first of all map all of our products into that vector space. So we take the product data, we give it to the embedding model. The embedding model says this product, here's an embedding that represents this product. It puts it into a vector database, which is its representation in a vector space. And then at query time, what happens is we go back to that same model, to that same embedding model, and we say, now we've got a query. Tell us about the products that are in this vector space. And it'll come back with, looking at the entire vector database, it will come back with a set of products that are similar, conceptually similar to that query. We can have more than just products represented there, as we talked about before. We could also say, hey, we want to put our how-to articles in that vector space and have them represented in the vector database, and it can pull that stuff back as well. So when I have a query about which refrigerator should I buy, you can have the embedding model can come back not only with the products that are close to the ones that you have, the features that you have referenced, but also maybe with a how-to guide that speaks specifically to those features. Once you've got that context, you go to the vector database, you pull back the similar products, you grab the product data that's associated with them, and then you take that information and you pass it to the generative model. And the generative model can do a number of things. It can come back again with an answer to your question. Well, you should probably think about, if you've got a large family that you just mentioned, you have a large family, you probably want to think about a 25 or larger cubic foot fridge. Or it could just say, this particular product is probably the one that meets the features that you have specified so far.
Mm-hmm.
Any questions about that or comments from?
Hey, Phil, how important is it that the embedding model you use at index time be the same embedding model you use at query time, or can you mix and match?
How important it is critical. So you want to use the same embedding model. You don't have to use the same generative model. You can use, maybe you use, say, GPT-4o for your index time because it's a little bit richer and you can pay the price for the additional time, or 4, say. But at query time, maybe you need something faster. So you can use a different generative model, but your embedding model, when you're trying to find the representation of that concept in your vector space, that needs to be the same model.
And so part of this is saying the source of, thank you for that clarification, Patrick. So part of this is saying the source of truth is your product catalog. And that's why we need to fix that data first. The source of truth is your product content, right? Because one of the problems with generative models is that they'll hallucinate. And what we're doing when we're using RAG is we're saying, use this source of ground truth, which is our product catalog and our content, and only answer the question if you have the answer from these data sources. Don't answer it and don't just say, I don't know, if you don't know the answer. Sanjay, do you want to comment on that? Because that's something we've been wrestling with and discussing and so on.
Yeah, exactly. Especially from product catalog enrichment perspectives. That's it. And again, going back to, you could bring additional sources to your catalogs. Just don't limit it to your product data and attributes, but that's where you might get this extra content to build that vector DB, right? To enrich it with a lot more data. Some of you guys might be using like RDF, or we're talking about like the semantic triples and all those, and so the whole idea of different types of entities and relationships, that's kind of where this idea of even a knowledge graph, maybe some of you guys are employing, could be also where some of this is managed as well, to give that context.
Yeah, so it's so it really does overcome those problems with generative models, right? Hallucination, citation, because we can have an audit trail when we're using RAG, and then the idea of that source of truth in terms of your content, your product information, your knowledge bases, all of that information that is that forms your competitive advantage. So I know there's challenges. It's not all motherhood and apple pie, or it's not all rainbows and unicorns, right? So what are the challenges that we have here? We talked a little bit about hallucinations. You want to go through some of these, Phil and Sanjay?
Sure, absolutely. So I'll start, and then Sanjay, you can fill in the things that I miss. One of the things when we talk about Gen AI in e-commerce in general is that one of the early things that we encounter is latency. When you're talking to a generative model, you are typically talking about a different level of expectation in terms of latency. It's it's maybe more normal for a conversation, but if you're typing in a search query in a normal e-commerce search experience, you expect more or less an instantaneous answer. LLMs in particular, generative models in general, tend to take longer. So that it influences our modality choice, right? So we might, that last bullet there, we might use a chat bot instead of a search box. Not saying that has to happen that way, but that's one of the things that we need to consider. From a hallucinations perspective, Seth, you already talked about some of the issues there and the importance of bringing local catalog data in to provide these answers. We've heard some of the news articles or news stories about mistakes that can be made. Like the last thing you want to do is recommend a product that your competitor offers and you don't, or maybe compare your product in a negative way to a competitor product. And those are things that you can build guardrails around, right? Not just the context of answer in the context of this catalog, but do not address questions that ask these questions, or don't address issues of personal safety or those kinds of things. And then cost is always a consideration in terms of these models do take extensive amount to host, extensive amount of resources, storage and compute to host, and of course to build. And so that comes back in the context of token costs. The more information that we feed to the model and the more information that we get back, the more expensive it can be. Open source models are alternatives that mitigate that to a degree. And the cost of these it's shocking how fast the cost is dropping to these things. I mean, that like when we think about the initial token costs, even 6 months to a year ago versus what we're looking at now in some of the models, it's exciting. So in terms of latency, though, there's a couple of other things that we can do to apply generative AI to the e-commerce experience in a way that sort of bypasses that. And Seth has talked extensively about how you can add to your product content at index time, and so that your data is enriched and your experience is better. There's also things that we can do where we can replay the signals or the experiences of prior users, apply the LLM and generative AI reasoning to those questions, and then pre-answer those queries. These are common queries that we all know how an e-commerce distribution works, where there's a lot of queries up front that get a lot of traffic, and we can have generative AI handle those offline and we would just pre-answer those queries. The other thing that I talked about the modality and the fact that, in a conversational search, the expectation for an immediate response is a little different. So having a chatbot in which you interact with and discuss the various options that are available to you on the results page, do I want this version or that version, or what's the difference between these three versions? That kind of thing can adjust the expectation on the part of the user as far as how fast the response should come back. And then one more thing I'll mention about just latency in general is there is a definite trend toward smaller, more dedicated domain-specific models. So these models are not as generally useful as a large language model, say like GPT-4o, but they can be very nicely tailored toward a specific experience, a specific catalog, or a specific task like query segmentation. Because they have so many fewer parameters, we're talking about billions instead of trillions, or even lower billions, like, or even in the high millions in terms of parameters. Those are much faster from a latency perspective, and therefore we can handle them sometimes at query time as well.
A couple of questions came up. One is, can you walk through or do a cost example? Like, what is the real cost calculation, or is there something you can reference that would give us a sense of what that might look like?
Yeah, sure. I'm happy to do that. So, I mean, it depends on which piece we're talking about. So usually, like, let's say that we want to take our catalog and we want to provide some of the additional enriched data that Seth walked us through earlier. So we're going to be looking at all of the tokens. So first of all, we talk about token cost. Think of a token as about 3/4 of a word. So if you've got 1,000 words, at about 1,300 tokens, something like that, right? And they're just chunks of words, and that's how typically these generative models are costed. Then there's the input tokens and the output tokens, and the costs are different for the two. They're usually, it's 3 to 1, depending on the model. Input tokens are cheaper than output tokens. So you've got then some kind of cost per thousand or cost per million. And I think it's about, like, again, they vary and the costs have dropped dramatically. I'm a little leery about putting this on record, but I think if I remember correctly, like Gemini Pro is like $15 per million for tokens. So that, it translates to, there's a lot of data that you can feed it before you need to worry about, what those costs are going to look like. But when you've got a very large, first of all, like a very large corpus or potentially a lot of search traffic, then those tokens do obviously add up. What you would do to cost this is basically make an estimate of how many tokens per record you've got in your catalog, and then you would multiply that by how many products you've got, and then you'd get some token count, and you say, if I want to feed all of this data to an LLM and get back some enriched data, that you would calculate how much data would come back. There's a token cost associated with that, and the model itself will have a cost associated with that, right? If we're talking about one of the public models.
Great. And I think we could. I'm sorry. Go ahead.
Well, no, I was just going to say, then do the math with that, and then you get your.
It can get a little bit complex. There's a lot of moving parts, but you get an idea. But it also has to do with the estimated traffic and the number of queries and the number of tokens that you're leveraging. I have a couple more questions that we can hit on quickly. I don't think we have. Let me see what else we have. But let's see. So here's one question from Dennis Connolly. How do you see fine tuning addressing some of these issues? Speed and cost, et cetera. And then Brian Zeev has another question. Can you provide an example of a small language model, task-specific, smaller model to the problem solving and the problem solving and relative size? So I see those as kind of related. One is about fine tuning, and we can define fine tuning in lots of different ways, right? Because when you are building an ontology, you're fine tuning. When you're looking at specific content, training content or operational content, that can be fine tuning. When you have a smaller language model, that can be fine tuning. But do you want to talk about a small language model or a task specific model and how that helps to mitigate some of these things?
Sure. Let's think about if you want your model to recognize the brands and then filter by brands, just as an example. Fine tuning could help with that, and a small language model could also be an approach to do that. But let's talk about the small language model approach. If you were using a large language model, you might not need to fine tune or do anything in that. You could basically just give it a query and it would recognize the fact that Kohler is a brand or American is a brand. With a small language model, what you're looking at is you're going to give it, you're going to give it a series of queries that reference those brands. And so that you now then, the small language model isn't going to have a lot of the general knowledge that it picked up the way that the large language models are, but you can feed that information in and it can learn the structure of a query and where the brand fits in that structure, as well as the brands themselves. So now you've got a very dedicated small language model that is trained to recognize a brand, and it will be able to pull that out effectively and reliably, even though it doesn't have a lot of general knowledge that it can apply to it. Like if you start to ask it other questions maybe in a different domain, it would fail, but you've trained it very well to do just that brand recognition piece, and it'll be able to pull that piece out of the query.
Sanjay, did you want to add anything to this, or do we want to move on to recommendations and personalization?
Yeah, I mean, you can start moving to that, but I can just add, one way you could start using like fine tuning is taking your analytic data from eCommerce, for example, getting all your searches and then kind of the highest performing or converting results for those who work in that area and feeding that to like a smaller model that doesn't have that visibility. But that's a great way, for example, to fine tune. And then that's something you can actually incorporate to do some continuous fine tuning or training as well. Just to comment out on that one as we're going through that, and it's going to touch on the next topic here too.
So again, when we start thinking about this is a big shift in how we're looking at e-commerce, because we can improve that experience, we can have better relevance, we can understand user intent. In the next slide, I'm going to walk through kind of a diagram that shows how we are picking up real-time digital body language, the signals from interactions, and it's integrating the non-product contents, reviews or recommendations or, how-to or, ways to get the best use of the product to bring that in to search results, or actions, be able to do something with that search result. And we also have the ability to use this across the entire customer lifecycle. So generative marketing, being able to do customer acquisition, being able to do better competitor analysis, right? There's so many different areas where generative AI is playing a role. And at the end of the day, you're really trying to improve that level of engagement by understanding that user, by responding to them in real time and near real time. And we do that by modeling the customer, understanding their attributes, understanding whether they're experienced or a newbie, whether they're a do-it-yourself or whether a professional contractor, whatever that might be. But all of this helps us define what the user needs across that life cycle and understanding the prior interactions. How do we contextualize where they are in order to inform recommendations? And here's a kind of an animation that I've used to say, let's take the customer life cycle, right? Becoming aware, shopping, making a choice, purchasing, and doing the acquisition, installing, using, renewing, whatever it might be, right? That's just a sample life cycle. We can kind of see there's a bunch of different pieces to this because we do need product information. We do need a content model. We do need to understand the customer in detail. We do need to understand attributes of that customer. And we need the knowledge and insights of brand managers and people that understand what content is necessary for the customer. We call this a high fidelity journey model because it represents the customer intent in metadata terms, right? A journey model many times, or a journey map, is a great, lever for kind of getting insights, but your systems can't respond to them. They're nice pictures and they give you insights. But when we do this in metadata terms, when we build that customer data model, that attribute model, and then we also track their dynamic model, right? So there's static metadata about a customer, their demographics, their industry, whether they're a personal end user customer, whether they're a B2B, B2C, whatever it might be. We have that data that does not change very quickly. If it's a B2B customer, what industry are they in? What's their role? What are their interests? And so on. If they're a B2C customer, what are the things that we know that don't change every day? Then we have the real-time dynamic metadata, the things that change as they make an intent. Here's a query. What kind of small appliances do you have? Well, our CRM system is going to manage that. And we're going to have, and you can see there's the dynamic customer model. You can see this little change in the attribute model up here in this little box. And this is where we have a knowledge architect that says, well, here's top of the funnel content. I know that based on brand management. I know that based on understanding the customer. Many of these have to be handcrafted at first, but then you can let your generative models take over, right? Remember, you always have to insert your perspective. You always have to insert your brand guidelines. You always have to insert your expertise and knowledge. And then we also have content, right? And again, the content does have to be enriched. It does have to have metadata. And we have our product data and we have offers. So all of these things, as we go through this, we're handling these different pieces, but they're changing that representation of the customer in that high fidelity journey model. And again, here's additional pieces of content that would be middle of the funnel content because we're doing product selection and we can give them a particular piece of content for that, right? So as we go through this life cycle, we're doing different things and we're picking up that digital body language of the customer and we're responding to that customer in near or real time, right? This is where all of these things come together with regard to building that ontology, understanding how our product catalog and our content are tagged and structured based on that reference model. That's the reference model, the knowledge graph and the ontology, and then using that along with the large language model to be able to inform and to present those pieces of information that are most relevant to the client, the customer. So you're picking up their digital body language, you're picking up their real-time signals, and you're also combining that with your product catalog and with your knowledge base and your support content, and all of those things that people need in order to present that in the context of what they're looking for as they go through that journey. This is kind of a new way of looking at this, right? Because we have to combine the structured content and the structured product information along with the journey and those digital body language. Sanjay, Phil, Patrick, did you want to comment on this? Thank you, Christopher. Christopher says great information. Thoughts, comments?
Yeah, I mean, I'll jump in and pass it on to Phil and the folks, but I think the whole idea is that I think it's we think about prompts and with what it takes for those who maybe have worked already with like ChatGPT to try to get it to understand and know you and understand your really what you've done and how to interact with you from a historical perspective, is definitely takes some effort, right? And so I think a lot of this trying to collect a lot of this data about that user and pass it is essential, right? Whether it's doing it programmatically through prompt templates where we identify what is important for the model to know about the user, right? And for example, what products they own or what products they purchased, or other things that might be important to that consumer, and then having that be consistent. And that does get into the whole problem, both with, again, search and generative models, that the idea of stateless versus stateful, right? How do you maintain that state of that knowledge of that user across all these touch points? And that journey is, of course, key to be able to feed that through. And that's where you have all these other systems helping feed that, right? That storage, that persistent storage.
Absolutely. And again, every time we touch them, anytime they touch us, they're giving us those signals, and those signals can be used to enrich our models and to be able to respond to that digital body language. Phil, thoughts? Patrick, thoughts? Oh, you're on mute.
I am so sorry. I'm usually a little better with the mute button. I just was going to say, I just love the reference of the multiple modes in which context can come in. Generative models do well when they are provided some explicit areas of context around which to form their reasoning. And this picture of all of these different forms of context that can be relevant, it's a nice way of looking at how we can capitalize on the reasoning capabilities or the generative capabilities of an LLM in the context of these different forms of context.
Great, thank you.
This is a good summary, Seth, and sort of to capture the whole conversation, there are a lot of ways to use generative AI in the context of e-commerce. We're just learning a lot about how it can be used, what works, what doesn't. There's a lot more to learn. There's a lot more to understand in the models themselves. The industry is changing substantially. So it's going to continue to change and evolve, get faster, get cheaper, as Phil mentioned. And so it's an exciting time to be in the e-commerce space. There's lots to explore together, and we would love to help you on your journey as much as possible.
Absolutely. And I was going to finish with related products because there's compatible products, solutions, kits, bundles, accessories. All of those things can help us with cross-sell and upsell. Those are traditionally difficult relationships to understand, but we're able to do this. And again, we talked about the knowledge journey. We talked about the fact that you can support knowledge access using RAG. That's the whole other area that is so important. So for us, we can help you by doing an e-commerce AI assessment. We can identify use cases and opportunities for those interventions. So please reach out. I'm going to leave our contact information up. We are right at the top of the hour. Feel free to look for this article or send a note for me for my book. This is all about knowledge management, large language models, and generative AI. And Sanjay and I just finished another peer-reviewed journal article that talks about this in very great detail. So as soon as that comes out, we'll share that with you as well. Whoops. But here's our contact information. So please feel free to reach out. Would love to hear from you. Connect on LinkedIn. And I really want to thank our panel. A tremendous job today, guys. Phil, thank you so much. Sanjay, Patrick, sorry you had the connectivity issues, but it was great to get you on board here. And thanks to our audience. And we will see you next time. Our next episode is coming up in, well, let's go up. I stopped sharing my screen. So, but it's coming up in 2 weeks. So if you want to join us, your existing registration will work, but that's going to be on generative engine optimization, revolutionizing SEO for the future. And that is on October 3rd. So look forward to seeing you all then. Thanks. Bye now.
That's all.